Hello dear viewers, I am Khan Bahadur, Assistant Professor of Statistics, and you are watching a video from my YouTube channel Statistics by Khan. Dear viewers, I hope all of you will be doing great. Dear viewers, this YouTube channel Statistics by Khan has been created for basic statistics with a view to help the beginner students of statistics, the researchers of all fields, and other learners of basic statistics. I have also a Facebook page and group with the same name, Statistics by Khan. You can visit them for steps related to basic statistics. Dear viewers, for better understanding of concepts in my video, I would recommend you to watch the full video. After watching the full video, I assure you, you will understand the concepts very clearly. In today's lecture, we are computing variance and standard deviation from continuous frequency distribution or from continuous group data by coding method. So let's start the lecture. Variance and standard deviation from continuous group frequency distribution by coding method. So as today we are computing variance and standard deviation from continuous group frequency distribution. So for this purpose, we are taking a continuous group frequency data. So let's take the data set. So this is the continuous group frequency distribution or continuous group data. Now we are computing variance and standard deviation from this dataset by coding method. Now again, the best way in the computation of any numerical problem in statistics is to write the corresponding formula first. So now the formula of variance and standard deviation from continuous group frequency distribution by coding method will become. So this is the formula for the variance from continuous group frequency distribution by coding method. Now if we focus upon the formula, so we need summation fu square. But in the dataset there is no u. It can be obtained from x, but there is no x as well in the dataset. So for this purpose, first of all, we will compute x from this dataset, which is the midpoint of each class. So let's compute x. We have made a detailed discussion about the computation of x and the computation of arithmetic mean from continuous group frequency distribution. So the interested viewer about the computation of x are referred toward that lecture. That is the computation of arithmetic mean from continuous group data. Over there we have discussed the computation of x from continuous group data in more details. But now over here we will directly write the values of x, that is. So now these are the values of x. Now what does u equal to? U is equal to x minus a divided by I. Defining u by this way is called coding, and this method is called coding method. And we have also discussed about the coding in details in the lecture about the arithmetic mean from continuous group data. So the interested viewer about the computation of u or the coding of u are referred towards the lecture of arithmetic mean from continuous group data by coding method. Over there we have discussed the computation of u or the coding of u in details. So after watching that video, the viewer will fully understand the computation of u or the coding of u. Now simply what does u show? U shows that a will be subtracted from each value of x and then that result will be divided by I. Now what is a and what is I? A is the arbitrary mean. Arbitrary mean is also called provisional mean. And what is I? I is the class interval. But do remember, whenever there is uniform class interval, so then in that situation we can use this method. If the class interval is not uniform, so then we cannot use coding method. Now if we look at the intervals across the classes, so they are uniform. Means all the class intervals are identical or equal. That is, there is an interval of 20 in each class. So that is why the class intervals are uniform. Now what is a? A is the arbitrary mean. And the arbitrary mean can be selected from the values of x. Any value of x can be taken as the arbitrary mean. But usually we take any central value of x as the arbitrary mean. Or the value of x against the highest frequency is taken as the arbitrary mean. Why do we take the central value of x as the arbitrary mean or the value of x against the highest frequency as the arbitrary mean? Because coding method is adopted for the ease of computation. So if we take any value of x in the center as the arbitrary mean, so it will help in ease of computation. Or if we take a value of x against the highest frequency as the arbitrary mean, so it will also help in ease of computation. So for this purpose, we are taking 114.5 as the arbitrary mean, which is against the highest frequency. So now in this case, a is equal to 114.5. So 114.5 is a. And I is the uniform class interval. So now what we will do, we will subtract this 114.5 from each value of x, and whatever we get, we will divide that by the class interval. So if we subtract 114.5 from 75.5 and the result is divided by the class interval 20, so we will get -2. Similarly, if we subtract 114.5 from 94.5 and the result is divided by the class interval which is 20, so we will get -1. Now if we subtract 114.5 from 114.5, so we will get 0, and if we divide it by 20, so again we will get 0. Similarly, from this we will get 1, from this we will get 2, from this we will get 3, and from this we will get 4. So now this is u column. These are the values of u. Okay, now if you look at the formula, so in the numerator of the first fraction we need u square. So for this purpose now we will square this u column. So next we will construct a column with the title u square. So this will become 4, 1, 0, 1, 4, 9, and 16. Now over here we need fu square. So we will multiply this f and this u square column. So if we multiply them, so the title of the column will become fu square. Now we will multiply the corresponding values of f and u square. That is, we will multiply 9 by 4, so it will give us 36. 10 by 1, so it will give us 10. 17 by 0, so it will give us 0. 10 by 1, so it will give us 10. 5 by 4, so it will give us 20. 4 by 9, so it will give us 36. And 5 by 16, so it will give us 80. Now, after the multiplication of fu square, we need the total of fu square. So now we will total this column. So if we total this column, so notationally it will give us summation fu square, and numerically it will equal to 192. Now in the denominator we need summation f, means we need the total of f. So now we will total this column as well. So if we total this column, so notationally it will give us summation f, and numerically it will give us 60. Further, if we look at this fraction, so we need summation fu in the numerator, means we need the multiplication of f and u and the total of the multiplicated values of fu. So now we will construct another column with the title fu. Now we will multiply the corresponding values of u and f. That is, 9 will be multiplied by -2, so it will give us -80. 10 will be multiplied by -1, so it will give us -10. 17 will be multiplied by 0, so it will give us 0. 10 will be multiplied by 1, so it will give us 10. 5 will be multiplied by 2, so it will give us 10. 4 will be multiplied by 3, so it will give us 12. And finally 5 will be multiplied by 4, so it will give us 20. So as we need the total of fu, so now we will total this column. So if we total this column, so notationally it will give us summation fu, and if we do the operations, so it will give us 24. Now one thing to note is that when we took 114.5 as the arbitrary mean against the highest frequency, so then in the next columns we got rid of the multiplication of the highest frequency. Means in each column we got 0. We have multiplied the maximum frequency by 0 and we simply got zeros. So this is the logic of taking the arbitrary mean against the highest frequency. Okay, now we have all the quantities which are needed for this formula. So now we will put these quantities in this formula. For summation fu square, we will put 192 divided by, for summation f we will put 60 minus, for summation fu we will put 24 divided by, for summation f we will put 60 square multiplied by I. Sorry, this is not I, this is I square. Multiplied by I square, so this will equal to 20 square. Now if we simplify the quantities inside the square brackets, so it will give us 3.04. That is, s square is equal to 3.04 multiplied by 20 square will give us 400. And finally, if we multiply 3.04 by 400, so we will get 1216. That is, s square is equal to 1216 unit square. So this is the final answer of the variance. Now for standard deviation, we will take positive square root on both sides of this equation. So if we take positive square roots on both sides of the equation, so it will give us s is equal to 34.87. So now this is standard deviation. Okay, so finally these are the variance and standard deviation of this continuous group frequency distribution by coding method. Hence, we have obtained the variance and standard deviation from continuous group frequency distribution by coding method. So this is the procedure for the computation of variance and standard deviation from continuous group frequency distribution by coding method. I hope this lecture will help you in the computation of variance and standard deviation from continuous group frequency distribution by coding method. Thank you for watching the video.